Hello, everyone. It's my pleasure to be presenting today at the Data for Policy 2021 conference. I'm a doctoral researcher at the Potsdam Institute for Climate Impact Research. And today I'm going to talk to you about a paper called Subnational Trends in Demography and Women's Socio-economic Development, a harmonized dataset covering 51 countries. And my submission number of this conference is 108. So data that have repeated measure over time are a rich and important source of information for researching and monitoring progress in development and well-being globally. There's extensive data that exists at the country level, for example, from the World Bank Open Data Repository, but at the subnational level, there is a relative lack of longitudinal data. But this regional heterogeneity can allow policy efforts to, for example, be more effectively targeted in specific areas that need like more attention or more support. So it's important to collect this longitudinal data at the subnational level. There's also a lack of granular data about women's living conditions. And as we know, today they continue to face in many areas of the world, economic, social, sexual discriminations. The Demographic and Health Survey Program is a program that has been developed in the 2018 by the US aid. And they collect survey data all across the world and make them available. And they're quite comparable across countries and across time. And they're based partly on women's interview with a representation at the subnational level. So this data is actually quite well suited to produce longitudinal data about women's living conditions. So what we did is that we constructed a data set based on many demographic and health survey data and also additional data. And these data set comprise socio-economic indicator at the regional subnational level and also climate indicators at the subnational level. The socio-economic indicators include the regional GDP, regional human development index, about 100 women's indicator based on DHS, fertility, child mortality, and also indicator of household well-being. And the climate indicators would include, for example, precipitation, anomalies, temperature changes, and so on and so on. I'm just going to expand a little bit on the women's indicators. So these indicators include many different type of categories. So you would have education, work status, marital status, energy and access to information, decision power, domestic violence, health, fertility preference, and nutrition. Regarding the spatial and temporal resolution, well, the indicators are available then for 55 countries and 479 subnational regions, and the countries are represented on this small map in the bottom. And the temporal resolution is from 1990 to 2018. So how did we do to create this database? Well, the first step was to harmonize the definition of regions over time. So as you may know, if you work with country level data and subnational level data over time, is that it's quite common that the definition of region within the country would change over time because of different reasons, political reasons, administrative reasons, and so on and so on. But when you want to construct a longitudinal data, you need that the same unit is the same over time. So if a region change, it's a problem. So what we had to do is to make sure that the regions stay the same over time from one survey year to the other. On this map, you can see the regions of Bangladesh before the harmonization on the left and after the harmonization. And what you can see is that I had to for sometimes group regions together. Yeah, I had to group regions together so that if a region had split over time, then if I group it, it's going to be the same as before the region had split it. But of course, we didn't have to harmonize all the regions. Some of the DHS regions didn't change their boundaries over time, so we didn't have to harmonize them. And other regions were actually already harmonized by a program called IPUM's DHS. So they harmonized about 30 countries. And what we did is that the countries that were not harmonized by the IPUM's DHS, we did this harmonization, and it allowed to add about a third of the regions. And so to add a considerable amount of data points. So now I'm going to show you how we constructed this data set step by step from the input data to the output data. So the first step, as I just mentioned, was the harmonization of region boundaries. So for this, we took about 200 DHS survey, and we collected all the region names and indices. And then there was like this very long process actually of matching the original region indices with the harmonized one, like looking at the change in boundaries on maps and so on and so on. So we obtained DHS regions that are consistent over time, as well as the associated spatial boundaries as shapefiles. Then the second step was using this harmonization of the boundaries and the actual DHS data. We could aggregate at the region level many variables, creating then the indicators I mentioned earlier. So for example, there would be the average number of education years for women, or the percentage of women in a region who have access to electricity, and so on and so on. Then we obtained this first set of socio-economic indicators at the harmonized region level. And yeah, as I told you before, we got about 100 indicators on the women's living conditions, fertility, child mortality, and also household indicators. And the second step was that we didn't only use DHS data. Since we had the spatial boundaries, the harmonized spatial boundaries, we could use gridded data at a small resolution and crop the region boundaries onto this gridded data and aggregate this gridded data to the harmonized region level. And then we obtain additional indicators, for example, the regional level of the GDP, the regional level of Human Development Index. And the third step was to do the same, but with climate data at also 1 kilometer resolution. It's the same process. We took the region boundaries, and then we cropped the climate data, and we could obtain at the same spatial level as the socio-economic indicators. We could obtain, for example, precipitation anomalies for the past 12 months, temperature change, and so on and so on. So this allowed to really combine a socio-economic indicator and climate indicators together over time and at the same spatial resolution. And the last step was to validate the socio-economic data. And for this, we used what we call the DHS stat compiler data. So actually the DHS, they already created a lot of these indicators at the subnational level, but not for all the countries because of this harmonization of region problem. So for the regions that didn't change over time, we could actually compare the data from the stat compiler with our indicators and assign that our computing framework worked is that these indicators would match. We also use World Bank indicators at the country level to also make sure that our data made sense. So a small example on the validation to see how it looks. So here, for example, you have 8 indicators on education. So for example, on the top right, you'd have education, the proportion of women with no education across the different region in the x-axis. And in pink is the result from our data sets, and in blue is the result from the stats compiler. And I forgot to mention that this is for one country that obviously didn't change its region over time, which is why we could compare with stats compiler. So for most indicators here, it's almost exactly the same. Actually, for example, year mean. So here it's different because the stats compiler actually uses the median and not the mean. So that explains the discrepancy. So what are the added values of this data set? Because one could say, okay, the DHS stat compiler also has subnational indicators. So what is added? So I think one big added value is this harmonization over time for much more region and more years, and that allows to obtain this global data set with much more data points and allow to make really large scale econometric and statistical analysis, or also descriptive statistics. The other big added value is also the fact that we can combine socio-economic indicator and climate indicator at the same spatial and temporal scale. And this really allows to study the impact of, for example, climate effects on different aspects of women's well-being, for example, or demographic outcome. We also created new indicators as compared to the DHS stats compiler. So for example, we created this, we computed this international wealth index, which is basically a measure of material wealth in the household, which takes into account, for example, whether the household has a high quality type of drinking water, whether the household has electricity, and so on and so on. And the DHS data for each country calculates a wealth index, but it's not comparable across countries. So we use the methodology developed to be able to compare the wealth index from one country to the other. And here we implement this to this data set, and so it allows to obtain the international wealth index at the subnational level for many regions and over time. Another important point is that we calculated standard errors for all of these socioeconomic indicators, and which was not done in the DHS stats compiler, and that allows to estimate the uncertainty in the indicators and to maybe weight by the standard error in some regression to make sure that the results are not too affected by some observation that have a high standard errors. And now a little bit on what you can do with this data set, which is what is ultimately the most interesting. So here we have really this data set on 55 countries and many subnational regions. And I think it could be very useful to estimate at a large geographical scale many different research questions. So for example, what is the effect of climate change on demographic outcome like fertility or child mortality? Also the effect of climate change on gender-related outcomes like maternal health, reproductive health, or also domestic violence or violence against women. And another example of application is to study the effect of energy access on women's well-being. And thanks to this longitudinal data, it's possible to perform fixed effects estimation because you have the same repeated observation over time. So what are the future work that we could do here? First of all, we have created a reproducible computing framework in R and R Markdown. So it's actually quite easy to add additional indicators that someone would be interested in. It's also possible to add other indicator based on gridded data. And another thing that we'd like to do in the future is so for the moment, this dataset is mostly based on women's indicators and living conditions. But to assess the gender gap and the evolution of the gender gap over time, it would be good to know what are the equivalent indicators, but based on men's data and on men's survey data. So as I said, because it's a reproducible computing framework, it's actually not so much work to reproduce this with the DHS men's recode, and this would allow to compare women's and men's indicators and to assess how gender inequality over time has changed. I thank you very much for your attention, and yeah, I'm looking forward to feedback and questions from you.